Hello and welcome back to The Space Between, one of the top astronomy podcasts in the world, and for that matter, the universe. My name's Kolby Van Camp here with Dawson Wagner, and whether you're tuning in from, Germany, Finland, India, the US, Italy, perhaps?
Italy!
We're glad that you're here and joining us in The Space Between. We didn't drop an episode last week. I had a bit of a family emergency, and all things have turned out for better. So that's good. I don't want to get into too much detail about that, but we appreciate your patience. Sometimes things just happen, and it stops us from recording, but it was a pain for me to not record, and I'm glad to be here with you today. Just a quick update on what we're doing with the podcast. First of all, if you haven't reached out to us on Instagram or on any of the platforms that we are on, you can do that. We now have a Facebook page. If you just put in the Space Between podcast on Facebook, you'll be able to find us. Also on Instagram at Space Between Pod. Just send us a message. We want to hear from you, and you can reach out to us in that way. You can also check us out on our website, www.spacebetweenpodcast.com. You can send us a message there. You can check out all of our content, and you can check out our affiliate, High Point Scientific. We're still trying to name the fan base. We've only gotten 2 suggestions, and we'd like more, okay? If you're using Spotify, it's right down. Just scroll down right now if you're using Spotify, and you can see where it says a little question box that says, what should we name the fan base? Just come up with a name. Come up with the name. We're currently jockeying between the Milk Dromedans and the Tweeners, and those are great. Those are great names. But we're still looking for more options. But if we don't get anything by the end of November, then we're just going to pick one of those 2.
We're gonna go with it.
We're gonna stick with it.
I like the Tweeners, but yeah, we'll see.
Yeah, I think it's pretty good. The names are creative, I think, but I would like to get a little bit more variety. So just reach out to us. Just let us know. If you're on Apple Podcasts and you can't access that Spotify poll, no sweat. Go ahead and just go over to our website, www.spacebetweenpodcast.com. You can check it out there. If you want to connect with us individually, you can reach out to us on Instagram, which a couple of you have started doing. So that was exciting. We've gotten a couple of different messages over the last couple of weeks, thanks to the interview that we did with Betty Maya Foote. So that was really cool. Dr. John Mather, we recorded with him last week, and he is going to have his episode drop a week from this Friday. We are recording today. What is today? The 3rd. So that would be the 10th. You will see the John Mather interview drop. So that's exciting. Be sure to tune in for that and check that out. And then just a heads up in terms of where we're sitting in the charts, we've made a resurgence thanks to you. We are currently number 17 in the Apple Podcast charts in the United States in astronomy. Very cool. Taking a hit in a couple of other polls, 145 in Australia in astronomy, 183rd in Italy in science. So we've jumped into Italy. It's the first time that we've broken into the Italy charts. So grazie to my friends over in Italia. And we have 183rd in the Italian science Apple Podcast chart, number 8 in the Italian astronomy podcast chart. So that's pretty cool. And then, of course, our usual suspects, number 26 in Poland in astronomy and number 23 in Argentina in astronomy. So that's pretty cool. I'm very proud of the number 17, though, for the United States.
We'll take it.
We'll definitely take that. If you're on an iPhone, just go over to Apple Podcasts and listen there. Just go do that. That'll be good. And now a word from our affiliate, High Point Scientific.
That's right, Kolby. High Point Scientific is your one-stop shop to getting the highest quality gear for your astronomy needs. Whether you're an amateur astrophotographer or a seasoned professional who studies the heavens, High Point Scientific has the perfect equipment for you. As we get dialed into the autumn and winter skies, High Point Scientific has a whole gamut of equipment, whether you need a telescope, a cooled astro camera, lenses for narrowband imaging, or whatever you're looking to find, High Point Scientific has the gear you need. Visiting the link in the description of this and every one of our episodes for your purchases will provide us with a small commission, which not only helps Kolby and I continue to make technical improvements for the show, but it also helps us make technical improvements to our astrophotography as well.
All right. So today we're going to jump into our topic. We've got a really fascinating topic, I think, for you today. And it's all about AI and the way that we are going to be using AI going forward. Oh, it's a hot topic right now around the world with ChatGPT and artificial general intelligence, and just the way that computers and the way that we think about computers are starting to move towards a can we create sentience kind of direction. And we're really close to that. Dawson, you're super into artificial intelligence and just the study of it. What do you foresee, just in general, before we narrow this down to space, what do you foresee coming up on the horizon with artificial intelligence, in your opinion?
In my opinion, I think that the way that we view life and the way that we view consciousness is currently being challenged in a variety of ways, and people are trying to define, what is consciousness, what is conscious, how can we help better clarify that? And I think with the advent of artificial intelligence and the ways that we're making, clones and types of ways of changing the way that we look at robots, where we're trying to make them more human-like. We're trying to anthropomorphize them. And so when it comes to anthropomorphizing things, that's when I start to think maybe on the horizon, we're just becoming a more diverse species, and that's the future is this implementation of artificial intelligence into our lives, to where we just need to accept any sort of forms of life, and if it's conscious enough to be able to have engaging conversations, whatever thing it might be and look like, then great. If it can communicate with us, then beautiful. And maybe that's the future of AI, is that it's helping us be more diverse and accepting of all sorts of different forms of life, whatever that life might be.
So one of my brother-in-laws is kind of a computer expert. He's a computer scientist. And we've often had the discussion where my father-in-law would say, AI and ChatGPT and all this stuff. And my brother-in-law says, pump the brakes on its AI, because it's not sentient, right? It's not artificial intelligence. It's just really deep machine learning. Can you break down the difference between artificial intelligence and machine learning and kind of what it does there?
Right. So machine learning, so how AI is built, or so how we view AI, because when we say so often now, we say AI, we think of ChatGPT now. And that's because there's large language models that have been built to be able to give feedback in response to somebody when they ask a question, in all of these different chatbots, and also the ways of generating art and conglomerating all these images. And you're training a data set over and over and over. You're basically, going through, and the larger you can build a data set, the more biases that you are able to identify and then put together to then make a well-rounded answer. And now, these answers are pretty ridiculous in some circumstances that ChatGPT has had and that people have talked about and exploited. They've also tried to force ChatGPT to have certain biases by saying certain things. And so really, when it comes to AI and the large language models that we see with ChatGPT, it's using machine learning to be able to process all that data. And machine learning is the analysis of so many things over and over and over, that then you're able to create a what they call a neural network. And you're able to connect almost in a way kind of like computers with nodes, and you're able to connect all these nodes then that it pulls information from, and then you're able to then come up with an answer based off of all those inputs of information. And so from my knowledge and what I know about large language models and how then it informs it, is it's able to run just a process like we do in our brains, except it takes a lot of storage space and a lot of things that it pulls from. And so that's why we can only build these data sets only so large. And so really right now, it's what we're trying to figure out is who are the people creating the data sets? What are their biases? Why are they creating them the way they are? And are they trying to do it in something that is in humanity's best interests? And then that's when you get into an argument of, what is humanity's best interests? Who is humanity right in trying to pursue what we want? Pro-human things. Well, what's a pro-human thing? And then that's when it gets more of a philosophical debate on what's pro-humanity. And so
Before we start turning into like Terminators and stuff like that.
Yeah, right. Yeah, it's like what really, especially if you look at what Elon Musk says, is he's pro-human, but he also is pro-environment. And so you can be pro-human and pro-environment, but some people don't think, there's some people out there that think that you can't be pro-human and pro-environment because humans are destroying the environment through the actions that we have and that we consume. through fast food and all the fossil fuels that we use and all the things on top of what has built, the modern day world. But if we're able to adapt those through cleaner energy and, electric cars and things that will eventually move us towards a way of hopefully not destroying the earth, but instead saving it, I feel like the only way that is possible is through, artificial intelligence and understanding so many things that would otherwise not be able to be understood if we didn't have these large language models and this AIs to help simulate certain things for us to better understand how to solve the problem at hand. I mean, that's how we solve so many problems in space, is through simulating, or not problems, but wonders of space. Is simulating the environment. Yeah, problems that you have, like what is dark matter? Well, let's simulate it in some sort of, thing here on Earth that maybe we can detect and see, okay, why is the galaxy having a star move like this, around the black hole, compared to, how a solar system would move. And that's how we know dark matter exists. And basically, I summed up, that was a short version of what dark matter is. Go back and listen to our other podcast about dark matter if you want more information on that.
Sure.
And there's just some things that I don't think we'd be able to comprehend or understand if it wasn't for large language models that then are able to be used as what we see as AI and what we deem as artificial intelligence, when in reality it's just computation running extremely quickly and being able to bring in a lot of different variables that then make us seem like it's conscious or sentient. But in reality, that's what humans are doing as well. We're just taking a lot of things into consideration and trying to process it. And then we have our own biases through ethical and moral things that we hold ourselves to, certain beliefs, but then that AI doesn't have that. And it more so just listens to everything around it and tries to take into consideration all the different beliefs. And yeah, it's really, the AI issue is also a very big human issue, and it points out a lot of problems that humanity has.
Sure. It points out a lot of biases that humans have. Well, and that is not a topic that I want to get into today.
No.
So we're going to steer away from that one in particular. But I'm looking here at an article from AIsolutions.com. Remember, all of our articles that we use in our episodes, we are now linking to a page on our website. So if you'd like to check it out there, you can, as a way to fact check us, but also we like to share where we're getting our information from. And so this AIsolutions.com article has a section about space exploration and how AI can be used in that. But it first quantifies. It says AI is usually understood in a collection of different ways now. And when you say AI, it's not the like Terminator artificial intelligence that we kind of think of. There is the artificial intelligence component of that. But AI now encompasses, in today's world, along with machine learning, cybernetics, problem solving, deep learning, machine learning, robotics, and, like you said, neural networks. And something that you had mentioned that I wanted to unpack for a second is the way that it's able to simulate things, which I think is really important. It was able to simulate how, so NASA, let me back up. NASA used AI to simulate how it would drop the Perseverance Mars rover on the surface of Mars, and use that as a model for then how they were going to do it. They used AI to create a prediction on how they were going to go about that, and then used that prediction to help inform their decisions, which I think is really interesting. And have you seen the Ron Howard Apollo 13 movie, with like Tom Hanks and Kevin Bacon? And
I haven't. I need to see
Dawson.
that. I know. There's some movies that you
Dawson,
talked
that's
about
like the
before
quintessential space movie is Apollo 13. Bruh. Okay. Well, that's all right. I'm going to leave that. I'm going to leave that. I'm going to leave that because that just makes my heart break. But there's a scene where when the Apollo 13 module has that explosion, they're like, what are we going to do? They have an issue of power, and it's like their batteries can only handle so much power. And then they're going to have to turn on a certain amount of computers in a certain collection of ways to not go above a certain power level and completely short circuit the entire ship. So if you do it wrong, they all die. That's kind of like what the stakes are. And they didn't use AI and machine learning because it was the 60s, right?
Right.
But or 70s, early 70s,
Probably
late
was a different
60s.
early form that, yeah.
Well,
I don't
what
know.
they did is that they had a duplicate of that module and every system that's in that module, and they said, okay, we know that these components have failed, so take them out. Now with what you have left, we're going to send in the guy that was supposed to go on the mission but got sick a week before. We're going to put him in because he's an expert on what he's doing, and we're going to have him simulate what would happen and what order we need to turn the computers on, whether that would short circuit the computers and the entire system. And so there's this really like tense scene where they have this guy that's in their lunar module like simulator, and he's with a bunch of computers, and he's sitting there and he's turning them on in different orders, and NASA go no go on this switch, and they're like go, so he switches it, and then it breaks the level of amps that they're allowed to go over, and they all die, right? And so it's kind of like, whoa, it's this crazy thing. Now we can use artificial intelligence to start to begin to work on some of that stuff that AI and machine learning were able to use, because now you don't need a guy that's pulling like a 36-hour day in a backup lunar module at, like the Houston Center at NASA to try and save the guys that are in space. Instead, you can start to rely more on computers, which I think is really interesting, but then it doesn't factor in for human error, right? How do you program a computer to account for the fact that humans make errors? Computers don't make errors. Computers make errors because like humans programmed them incorrectly.
Yeah.
Right. And things fail because of #physics and thermodynamics and friction and parts eventually over continuous use fail, and then you see system failures and stuff like that. But if everything in the perfect scenario for a computer, it should just work because it's done correctly. So how do you account for human error in that? And that's something that you have to consider when you're looking at some of these life or death situations. We're going to try and send a collection of astronauts to Mars, and we use this AI program to simulate that. Well, the AI didn't account for the fact that Jimmy, the astronaut, pressed the wrong button, and now what? Now what do you do? Right? And so crazy, but how do you get to that?
Yeah, how do you get to taking out the errors?
Yeah, but then how do you just account for it, I think, is a question, especially when it's intense, high-pressure scenarios where it started as AI predicted what would happen, and now you have to have humans do it, and they have to do it the exact same way. That's tough.
Yeah, so it's to me, it's the bridging of this divide between computers and humans that we don't really understand how it's going to happen, but there's different methods that people are discussing of implementing, computer brain interfaces that are outside of your brain, or you just put it on as a cap or some sort of, helmet of some sort that's able to read your brain waves and help you communicate. And there's a lot of invasive, chips as well. Neuralink, that's a big example. Elon Musk has this company that is experimenting with chimps, where you can go on YouTube right now and look at a video of a chimp, playing with what was it, Pong? I think it was Pong, and it was basically using its brain to play Pong. And
that's crazy.
It was hooked up with the handle, and then they disconnected the handle, but the chimp still kept using the handle, thinking the handle was working. But then they showed the computer and the neural interface that they had connected with the chip in the chimp's head, and it was still having all the same brain waves that were sending a signal to the computer, then that was allowing him to move the chimp to move the Pong paddle up and down.
That's crazy.
Yeah, and every time that it hit to send the Pong back, the chimp got a reward through a smoothie. And so it was like a banana strawberry smoothie that it was like sucking on and like was getting a reward every single time it got a hit successfully from hitting the Pong.
Yeah.
So it was kind of wild to see, okay, this is possible inside of a chimp. If it were to be implemented inside of a human, then what would the cognitive capabilities be like, and how would that then allow us to then connect with things that we maybe haven't been able to sense or connect with yet because we haven't crossed that barrier or bridged that gap between, the internet and our brain interfaces? Are we able to then download things, upload things, and
It's
that
very
really
the Matrix.
It's very Matrix, and it's very scary for a lot of people to think about. But at the same time, I think about the communication capabilities and the ability. It's inspiring to think that I could possibly one day talk with my dog and have like a conversation about like quantum mechanics in regards to...
I don't know if your dog would be able to handle that. nothing against Uni.
You're right. Nothing against Uni, but like I think if I educated him, he had questions about the world or like why certain things are the way they are, then maybe I could help him better understand what's going on. And so and do that with any animal really. Like dolphins, it's crazy how they can communicate. Right? Like they have not telekinesis. What's it called? Something that was able to send brain like
they use like sonic. They use like sound waves and stuff like that to communicate in some way with each other.
So there's certain wavelengths and frequencies that I don't think we've been able to access yet because we haven't bridged this divide between us and whatever we're building with this artificial general intelligence and artificial intelligence that will help us advance to the one day be able to communicate and sense maybe what's out there. What are the signals? What are the things that are maybe out in space that artificial general intelligence, AI, whatever it's called in the form in space, that they are already communicating with on a specific wavelength and frequency and using maybe dark matter and dark energy somehow to travel and communicate and utilize the understanding of the universe that we have not unlocked yet.
Sure. As I'm looking at this AIsolutions.com discussion about how AI is used in space and space exploration, it gives a collection of things that AI is currently being used for right now by NASA and the European Space Agency and all these other space-related organizations. And the first thing that it says is that mission planning, so the entry, descent, and landing flight dynamics team had to rely heavily on AI for mission planning and complex scheduling systems to get through the 7 minutes of terror during the Perseverance mission, which is the Mars rover landing. Mission operations, it says AI is used for autonomous operations for space missions through the European Space Agency's technology transfer program. The Italian startup company AIKO developed a software library called Mirage that is used to enable autonomous operations for space missions, which is pretty cool. Data collection is another one. It says over the past decade, the volume of data we've collected from Earth-observing spacecraft, deep space probes, and planetary rovers has increased significantly for ground infrastructures used to determine and deliver the data to multiple end users. Having the ability to optimize the vast amount of data collected from scientific missions and analyze the data using AI automation positively impacts how data is processed and transmitted to the end user. Autonomous navigation and maneuvering. And it says, as we saw during Perseverance's arrival to Mars, ground operation communication capabilities do not always allow for continuous human monitoring and operations of the spacecraft. Autonomy in navigation allows for spacecraft to travel through interstellar space and perform complex maneuvers for arriving at and landing on distant celestial objects. Human intervention to control a spacecraft cannot occur in real time from the ground due to the lag in communications in deep space. On-orbit spacecraft maintenance, you have AI that does on-board maintenance for different projects. It says, as we investigate the future of space exploration, we cannot overlook the need for spacecraft maintenance missions. And remember, and you'll hear about this in our episode next week with Dr. Mather. We'll give you a little tease. We were talking about the size of telescopes, and he says, I have a telescope proposal that's on my desk right now of a telescope that is built by AI robots that assemble it itself in a Lagrange point or like multiple thousands of astronomical units away from us. And it uses its own robots to build itself. Crazy.
Yeah. I wonder if the term AI robots, is that like repetitive? Or do you think that it's good to specify? Because are there different types of robots that like could be...
Yeah, I think so.
Because there's like AI, just runs in a system. So you're teaching these robots just like one specific, like you do this specific task. that's part of the bigger picture of all these robots that then build the telescope.
It feels like to me that like AI is the brain, and then all of the so-called AI robots are the extremities that are being controlled by the brain, right? And that's what it feels like to me. And you know, you talked about a neural network. Then you just network all of these different robots into one place. Bam, there you go. You have a central computer or a central machine learning program or artificial intelligence program that runs everything. But then different robots have different jobs that they do.
Yeah, it's interesting because then you think of like, okay, if you have all these different things that can do different jobs, then if you bring those all together, that would be technically an artificial general intelligence because then it can think and work like a human where it has a bunch of complicated different tasks that it has to achieve, and it holds those different simpler AIs accountable basically, where it's like, okay, I'm going to send you out, you do this, accomplish this, and report back. And you AI do that, and then the artificial general intelligence just basically keeps tabs on all of it. Just like we currently, in a way, are that artificial general intelligence, are that one that keeps the tabs on the AI.
Yeah. And so we've come to an intriguing situation where this is reported by phys.org. It's from the beginning of October, so this article is a little bit old, but I think it's still absolutely applicable to what we're discussing, because this is where you talk about how much do you want human intervention in the exploration of space, and how much do you want human intervention with how AI is being used to search throughout the cosmos for things, even here on Earth. And it says, this is the article title, and this is released by Northwestern University. It was a press release that they sent out. It says, first supernova detected, confirmed, classified, and shared by AI. And so again, Northwestern University, it says a fully automated process, including a brand new artificial intelligence tool, has successfully detected, identified, and classified its first supernova. Developed by an international collaboration led by Northwestern University in Chicago in the United States, the new system automates the entire search for new supernovae across the night sky, effectively removing humans from the process. Not only does this rapidly accelerate the process of analyzing and classifying new supernova candidates, it also bypasses human error. The team alerted the astronomical community to the launch and success of the new tool called the Bright Transient Survey Bot, or BTS Bot for short, this week, or a number of weeks ago, because this article is written in the present tense. In the past 6 years, humans have spent an estimated total of 2,200 hours visually inspecting and classifying supernova candidates. With this new tool now officially online, researchers can redirect this precious time towards other responsibilities in order to accelerate the pace of discovery. Here's a quote from Northwestern's Adam Miller. For the first time ever, a series of robots and AI algorithms has observed, then identified, then communicated with another telescope to finally confirm the discovery of a supernova. This represents an important step towards further refinement of models, which will allow robots to isolate specific subtypes of stellar explosions, and then ultimately removing humans from the loop provides more time for the research team to analyze their observations and develop new hypotheses to explain the origins of the cosmic explosions that we observe. We achieved the world's first fully automatic detection, identification, and classification of a supernova, added Northwestern's Nabil Rahimutullah, who co-led the technology development with Miller. This significantly streamlines large studies of supernovae, helping us better understand the life cycles of stars and the origin of elements supernovae create, like carbon, iron, and gold. And so, super cool that they've developed a program that can use telescopes across the world. It's not just like they're all connected through like the internet. You use telescopes across the world. A telescope in Colorado detects there's this blip in the sky that could be a supernova. I think that went supernova. The AI detects that from the telescope, reads the information, understands what is being told, and says, okay, let's double check that with a different telescope and see if that's an anomaly here in Colorado or if that's actually a supernova candidate. So they send it off to Australia, and that telescope then pointed at the same spot in the sky and said, yep, that looks like a supernova to us too. And this AI brain is communicating with all these different telescopes around the world to collect data and confirm data, classify what type of supernova candidate they think it is, and then share it with the science team. And so like you get an email, I guess this is super like dumbed down, but you get an email that says, hey, I'm your AI robot and we just discovered a new supernova. That's 12,000 of them today. You know,
Wow,
like
yeah,
which is crazy because you had to do that by hand yourself. But that brings an existential question that I want to propose to you. That's super cool. It reduces the amount of time that scientists spend like actually out looking at the sky so they can devote that to other stuff. But what are we going to miss because you don't have humans? There are fewer humans now out looking at the sky, you know?
What have we missed because humans have been looking at the sky?
I was at the
throw it back at you.
You asked me the,
I just
the
threw it
opposite.
back at you because you're right. We could miss things more if it's just an AI that's like, or some sort of, robots that are having the observations that they're looking for specific things, but maybe there's things that they aren't looking for then that they miss, right? Then that somehow humans then could observe and then be able to break down and then hypothesize and come up with, but that is the form of running a simulation that humans have done, time and time again with different hypotheses about what's out there and how we come up with the theories that we do. I think that, the replacement of humans, really what's at the bottom of this question is just like, are humans just going to be replaced from the picture of being able to observe things, in the sky and having astronomers be astronomers? No, I don't think they're going to be replaced. I think that ultimately we're going to use this as a tool, and it's going to be able to help us, and it's not just going to like completely remove us from the equation, at least in terms of observing things we haven't been able to observe. Because regardless of how much an AI must know about something and detecting supernovas, it still is going to need to be written about and talked about and discussed and spread and communicated. And as much as AI can write that stuff up, is it going to be just consuming itself and sharing with itself? No, it's still going to share with humans in some sort of form and informing humans on what they've discovered and having humans discuss with other humans. So like, it's just hard to imagine a world where like only robots and AI are communicating and replacing everything. Like, and it's some people, it's a stretch of the imagination to say it's going to replace all things because there's so much human involvement embedded in every aspect of what we do that how do you go about replacing that so quickly? I don't think it happens quickly. If anything, of what this dystopic world of only AI and robots that some people say could replace everything, it would take hundreds, if not thousands and thousands of years. I feel like,
Interesting.
I mean, as fast as we are developing things, yes, as fast as we are changing as a society in the past 100 years, I think the removal of humans from the equation is a lot harder than what some people think.
Yeah. Well, the thing that you can't program into a computer, which is why it's important for there to always be astronomers that are looking at the sky themselves, is curiosity. You can't tell a computer to ask questions about things that it doesn't understand. Like, you have to tell the computer to do that. Like, how do you program a computer to be observant enough to say, oh, that's weird, I wonder what that is, And humans just do that naturally. They look up at the sky. I'm used to seeing this constellation, and there's something different about it tonight. Why is that different? What is that thing that is different? Oh, it just flew away. Well, it's probably an airplane, or it just exploded. What did I just witness? And how do you program a computer? It's like, you've seen Interstellar, right?
Of course.
Yeah.
Yes.
Well, and it's like the moment where Matt Damon talks about the reason that they couldn't send computers out into space and robots to go and do the exploration thing is that they can't program a sense of fear into computers, right? So if it was in a life or death situation, it wouldn't preserve itself. It'd just be like, whatever. And then you wouldn't be able to get that kind of response, that self-preservation response. Can you program curiosity into a computer to just get it to look at the sky and ask why. Like that's what scientists do.
Yeah.
Right? Is they find gaps in their research and they ask why. Can you program a computer to do that? Maybe. But as far as I know, at least not right now, no, you can't. Which is why I still think you still have to have humans looking at the sky.
Right.
You know?
Right. You have to have humans' involvement, because how else would we be able to spread the information right now that we're able to spread and talk about and break down and better understand? And there's so many aspects of replacing, the human involvement with astronomy and all sorts of different fields that AI is involved with, that I only see a path forward of us working with AI in tandem and having a group effort of moving forward the world to a better place that would allow better communication and breaking down of language barriers that we're not able to break down because we don't have the technology to be able to do that. Like, we talk about aliens so often, and what they might be and how we might communicate with them. That all comes down to if we're even able to communicate with them or even understand what messages they're sending us. And how do we do that? Well, I think that AI is part of that answer.
No, and I think AI is definitely a part of that answer as well. Coming up next, we're going to dive into the discussion of, is AI what we should be looking for instead when searching the cosmos? All that and more coming up next on The Space Between.
Hi, my name is Ryan Gilbert. I'm a former sports broadcaster for Wildcat 91.9, K-State alum, and basketball recruiting editor for GoPowerCat.com. The last academic year was a historic one for the station, as Wildcat 91.9 was named the best college radio station in the nation by the Intercollegiate Broadcasting System Awards, the first national championship in program history. However, despite all the awards and success, the budget for Wildcat 91.9 continues to be cut year by year. I'll be perfectly frank with you. Either Wildcat 91.9 finds new funding through charitable giving, or it will permanently go off the air. That's why I'm asking you today to consider making a tax-deductible contribution to the station so that the longest continuously running college FM radio station in the nation can continue to train the next generation of media stars. To make a contribution or discuss options for creating an endowment fund, please reach out to us at www.wildcat919.com/donate. That's www.wildcat919.com/donate. Thanks so much. Go Cats, and always remember that at Wildcat 919, you belong.
And now a word from our affiliate, High Point Scientific. We're starting to exit galaxy season, RIP. But that means one of our biggest friends in the night sky, the Orion constellation, is starting to hit the skies here in the northern hemisphere. And that means that I'm going to be out and investing in a range of new gear to get my best photos to date of the Orion Nebula, the Horsehead Nebula, and perhaps even the Greater Barnard's Loop that's also in the Orion constellation. I'm going to be frequenting High Point Scientific, and I suggest you do too for all your astronomical needs. Visiting the link in the description of this and every one of our episodes for your purchases will provide us with a small commission, which not only helps Dawson and I continue to make technical improvements for the show, it helps us make technical improvements to our astrophotography as well. Thank you very much to High Point Scientific. Welcome back to The Space Between. Kolby Van Camp and Dawson Wagner here with you today, discussing artificial intelligence in the way that it is kind of starting to seep into our lives. Is it nefarious? Is it not? Is it exciting? It's a little bit of everything, I think. Probably. Floating around here in the space between. We had gotten into a very intriguing discussion about how AI is used to help astronomers observe the sky and whether you can program curiosity into a computer. Then Dawson posed the very fascinating question. When using AI, I think as we begin to expand our reach into the universe and we get to start looking for different, dare I say, extraterrestrial intelligences, that using artificial intelligence on our side is going to be super helpful. But I counter with an article written by space.com the beginning of October. A guy named Keith Cooper wrote this. And the question is, in the search for alien life, should we be looking for artificial intelligence instead of like biologics, carbon or silicon-based life forms? Should we be looking for artificial intelligence instead? And I think that's just an absolutely fabulous question. It's such a great question, and that I think fewer people are asking than they should be. And the article opens with, is biological life common in the universe, or should we be looking for artificial robotic intelligence in the search for alien life? An increasing number of scientists suspect that if we ever do make contact with an alien life, we will be communicating with a computer. The thinking revolves around an event called the singularity. This term, borrowed from mathematics, signifies a point where our knowledge of math and physics break down and we can no longer accurately characterize what we're trying to describe. That's also why the center of a black hole is called a singularity, because physics just goes out of the window. Like math and physics make no sense in the singularity
Right.
because it's so compressed. And then it says that. Oh, I didn't even see that in the article. It says a black hole singularity is a good example of this. I'm so smart. Big brain time. In computer science and technology, the singularity describes the moment when artificial intelligence develops so fast that it results in superintelligence, an artificial general intelligence, as opposed to the very specific machine learning algorithms that we have today. They experience runaway growth in computing power and intellectual ability, and the superintelligence would grow so far ahead of us so quickly that we could lose the ability to understand or explain it. Computer scientists have been speculating that the singularity could come soon. Most predictions seem to agree on the period between 2030 and 2045. What happens beyond the singularity in anyone's guess? You were shaking your head, and I have to ask, do you think the singularity happens between 2030 and 2045?
I can't.
How do you even make that prediction?
You can't. Dude, I feel like it's almost like Drake's equation.
Did you use AI to predict when AI was going to
Yeah, I bet they did. I bet that's something. They ran a simulation. It was like, well, 2030, 2045, like roughly. I don't know, dude. It's just the same like Drake's equation, right? Where Drake's equation puts all these different variables that we kind of have an understanding of, how many different types of exoplanets could be out there, and comparison to all the galaxies and all things, and the chance of life being out there. It's like, it's almost the exact same with the singularity, of the chance of having the singularity if you put in all the machine learning algorithms that we have and all the specific different AI chatbots and all the different artificial intelligences that we have in different forms could eventually maybe form into a singularity with there's so many variables. And I just feel like 2030, 2045 is it's like saying we're going to be on Mars by 2030. I'd be great. I want it to happen, and I think that'd be cool.
I think that's much more realistic.
Isn't that it? Yeah, I know. Yeah, it is. It is. But I think we have to go to Mars first before we even have a singularity.
Yeah.
Or any idea of what a singularity might be. I don't know.
I don't know either. Well, as the article continues, it says there's no guarantee that the singularity will come to pass. Many academics remain skeptical. These academics, as we are communication scientists, remain skeptical, folks. However, if it does, the timescales would be remarkable, given that it is predicted to occur just 250 years after the Industrial Revolution. God, that was a mouthful. The Industrial Revolution. 130 to 140 years after the Wright brothers' first powered flight, and a century after the atom was first split, and 50 years after the invention of the World Wide Web. If we are a typical civilization in the galaxy, the singularity would seem to happen early in the life of a technological species. Now consider the age of the universe, 13.8 billion years. Assuming that life has been able, in theory, to develop and evolve for the vast majority of that history, alien species could be billions of years older than our solar system, and many billions of years older than Homo sapiens. That would have had plenty of time to pass through the technological singularity, which is why so many researchers studying the search for extraterrestrial intelligence, or SETI, are convinced that technological aliens will be artificial intelligence. Quote, this is very much at the vanguard of thinking in some sections of the SETI community. Amon Karens, an astrophysicist and SETI research at the Jodrell Bank Center for Astrophysics at the University of Manchester in the UK, told Space.com, we ourselves are very close to realizing artificial general intelligence, and there's an expectation that once you reach that point, it can then accelerate away at a very fast rate and quickly outstrip ourselves in intelligence. And so then it goes on to searching for superintelligences. Suppose alien life was some sort of a superintelligence that had gone way past the singularity. What would that mean for SETI? SETI focuses on the search for radio signals, the same kind that humans transmit, and there are still very good reasons for searching the radio spectrum. Radio waves can permeate the Milky Way galaxy. There are relatively simple means of signaling, and aliens would suspect that our astronomers were already studying the universe in radio waves and would therefore be more likely to spot a radio signal. A superintelligence billions of years older than us, however, might have long since moved past radio and might not even care enough to attempt to contact primitive life forms on Earth. It's a fascinating point. I was listening to an interview that Joe Rogan did with, who's this scientist that was the proponent that Oumuamua was like a solar sail. He's at Harvard. God, his name just is absolutely blanking in my mind right now. He's a German guy, a German-Austrian.
German-Austrian.
Yeah,
scientist.
Yeah, I'm so blanking. Just Google it and you'll look it up. Just type in Oumuamua in Harvard and he'll pop up. He and Joe Rogan were kind of talking about this, and he said, "Why on earth would aliens even give two craps about us? Because if they're that super intelligence, they don't care about us. Mm-hmm. We're just some speck on an anthill in the middle of nowhere, you know, like unless they're coming to terminate us, you know, Nick Fury ant boot, right? Mm-hmm. Like unless they're coming specifically for that reason, why would they even care? They're so far ahead of us. Why would they even care?"
Avi Loeb.
Avi
Loeb.
Yeah, thank you.
Avi Loeb was on Joe Rogan's podcast talking about Oumuamua.
Yep. Why would they care?
Why would they care?
I think that's such a great point.
I just think that they already know we're here. You know, I feel like there's got to be some sort of thing that is out there that is just like monitoring us and keeping tabs and making sure, hey, don't let the chimps blow themselves up. Like, okay, we'll step in now, or I don't know. Like, I just think that it's an interesting concept, and that's something that Joe Rogan time and time again has talked about on his podcast. Is like, I know we're hyping up Joe Rogan right now in a way, and some people have different views of him, but he brings on very engaging scientists, different politicians, people from all over the spectrum that really provide context to some interesting, engaging topics.
Well, regardless of whatever you think about Joe Rogan as a person or politically or whatever, he's a gifted interviewer because of the way that he is able to extract questions from people from what they're saying, right? Synthesize different answers and responses to how people are talking to him. Right. That's genius. That is super skilled. Yeah. And that's a lifetime of working that skill that I respect the heck out of him for. Like, there are some things he says, I'm like, man, yeah. I could take that or leave that. But
I do criticize, like, when he talks about certain sources that then did fact check or have some sort of information that they released that he just hadn't seen yet, and then that's when I'm like, oh, come on, man. Like, now it's kind of spreading misinformation, and so that's where people criticize him the most. But when he's engaging in topics that are very hard to understand, like aliens and concept, he's obsessed with aliens. I mean,
Joe Rogan, totally obsessed with aliens.
He's like, you just see his logo. I mean, he has an alien like UFO that's above his logo but in the background behind him, and it's a very intriguing podcast that allows you to expand your beliefs and your wanting to understand what's out there. And I feel like with Avi, he was able to kind of break down some of the complicated things around, you know, understanding aliens, and then also asking kind of just like questions that come back to ego. Why do we think we're so special that they'd come and, you know, talk to us? Why us? You know, it makes sense where I'm thinking they're just monitoring us and making sure we don't blow ourselves up.
Did you see, I don't remember where I had read this, or I heard it somewhere in a podcast. I think it was with the Cool Worlds podcast with David Kipping, where there had been in the 60s, 70s, somewhere in that time, when they were really trying to figure out, like, they're in the middle of the Cold War. They're like, how can we, like, not nuke each other into annihilation, into complete destruction, but how can we use that for, like, a good thing? Somebody proposed, and it became like a leading idea until somebody said, what if that sends the wrong message? Somebody proposed, what if we took all of our nukes and put them, like, outside of our atmosphere and, like, blew up all of them at once to, like, send a signal? Like, what would that look like if we just, like, went out to a Lagrange point and detonated all of our nukes at once and then made this, like, huge explosion? Would that gain attention from anybody?
Dude, I'd want to know
as like a signal.
I'd want to know if that could maybe cause like a black hole to form. Because you're
I don't
having
think you
such
have
a
enough.
right. I know it has to
You
be
need
like
mass.
You need a huge star that's like 10 times. Yeah, that's true. Can we even? I know we simulate like the heat of the sun.
Our star
from
hasn't even collapsed on itself.
Yeah.
Our star won't collapse on itself.
Right.
So
right. It's it has to
wouldn't
be
create
a
a black hole.
major star for it to be able to create some sort of black hole. And so
Well,
I feel like that's probably not possible.
the interesting thing is that people were kind of like, oh, that's actually kind of an interesting idea. What if we detonated all of our nukes?
to send a
out
signal.
to send a signal and see if anybody would see that and respond to it. And somebody was like,
I think that's-
what if they thought that it was like a sign of aggression and then we got blasted into oblivion? Like what if a little green guy was flying by and saw them detonate all of our nukes all at once? They'd be like, get him.
Be like, wait a minute, what is the monkey doing? yeah, back it up. Yeah, there's like different ideas of that in regards to like Mars and how Mars is such a cold, like barren place, and it has like the possibility to create more of an atmosphere that then you need more global warmth, more like what in our way carbon. You need more carbon. In the atmosphere there to be able to create, the life that we might have here on Earth. And so Elon Musk kind of had this idea of maybe we should just blow up nukes on Mars and then have it create, a warming effect that then would eventually, surround the planet in an atmosphere and create an atmosphere for us to be able to live on. And a lot of people refuted that idea and said that,
radiation. You might create an atmosphere, but it would become uninhabitable.
Yeah, for hundreds and hundreds of you'd have to really that's like long scale. And so I think that the whole idea of blowing up our nukes to try and either send a signal or create life of some sort is probably not the best path forward, but it's a fun one to engage with because it implies that we somehow would get every single nation to work together to give up their nukes and blow them up for one cause.
Hey, Putin, I need all your nukes. We're going to blow them up in space. I promise. Trust me, I'm American.
Yeah. Hey, all right. Hey, China, Russia, North Korea, US, let's all, EU, everybody, let's all pile our nukes together and let's create a crazy light show in space.
It just turns into like a Clint Eastwood movie when they're all got their guns out. They're like, I'll put mine down when you put yours down. Put it down. Well, only when you do. Well, when I do, you will. And then
and who's in charge of sending them up on the rockets? What do we just trust Elon and say, all right, Elon, send them up. Make sure you don't blow it up on your way.
So in that there's a separate fascinating discussion. Are you familiar with the Kardashev scale?
I've heard of the Kardashev scale. I need to be a refresher though.
So this article from space.com talks about it. Says beyond looking for signals, recent SETI efforts have been considering a broader concept of technosignatures, evidence for extraterrestrial technology or engineering, which is why creating telescopes that can detect exoplanets and be able to view the stars and the exoplanets with higher detail is super important because it says possibly on an enormous scale, for it to be noticeable to us, we need to look for these specific technology and engineering phenomena. This might be one of the ways to detect an artificial intelligence, since the search for technosignatures is agnostic about why the aliens are doing what they're doing. Beyond the singularity, such reason might be difficult for us to discern. It says a superintelligence would need a lot of energy to facilitate the computations of its CPU. In 1964, Soviet astrophysicist Nikolai Kardashev proposed that what would become known as the Kardashev scale, in which increasingly technologically developed civilizations harness the total energy first of its planet. So that's a type 1 or a level 1 civilization. You have to harness your planet. Once you can do that, then you go to harnessing your star, which is a type 2 or a level 2. And then you move on to harnessing the entire galaxy, which is a type 3 or a level 3. In principle, the latter two levels would be achievable via Dyson swarms or a Dyson sphere of solar energy collectors around the civilization's home star and then around every type of star and black hole in their galaxy. According to the Kardashev scale, a type 2 civilization could harness 4 times 10 to the 26th power watts. A type 3 civilization could reach 4 times 10 to the 37th power watts. It says a superintelligent a superintelligence might even opt to live inside a Dyson swarm. For example, in a Matryoshka brain, a series of nested shells of Dyson swarms in which the innermost shells absorb sunlight, use the energy for processing, and then emits the residual heat energy for the next shell to pick up, and so on, so that you don't waste any of the energy. So it's like a line of shells, and the first one soaks up, and then any excess is knocked off. And then the second one behind it soaks up that one, and then the excess comes a little bit less, a little bit less, a little bit less. And then you harness all of it. That's crazy. It's like something out of a science fiction.
No, it's full
book,
science fiction.
You know?
Yeah. The Kardashev scale
it's crazy.
Is definitely, like, when I heard Dyson sphere for the first
I thought of
time,
a vacuum.
I was like, "Why? Yeah, Dyson.
Dyson, like Dyson vacuums." I thought of like my mom's vacuum.
Well, it's hilarious. I think that, like, with the Dyson sphere idea, though, and like the controlling of energy at different scales is so fascinating to me. Like, I can only go so far with the example, but like being able to control energy at the scale of the entire universe would be something that I don't know what it would take, but I think we need artificial intelligence for it.
Oh, yeah.
Like,
nah.
That's one thing.
No, we don't need that.
Like, built into the Kardashev scale, the example I keep coming back to is like the fact that only all of that is achievable with implementation of artificial intelligence.
You need a significant technology boost
and some sort
to
of
be able to utilize that.
Yeah, blending of taking away, like, no way our human bodies are going to be able to survive in like the environment of space and in different forms. So it's building a different form that we would need to do to be able to achieve the things that the Kardashev scale lays out.
Yeah. Well, and the final question that this article poses is, what would this superintelligence that we're speculating exists somewhere in the universe do in its spare time? And why would it be important for us? It says spotting alien art might not be so easy. Art is cultural, so we would not know what is beautiful to them. However, the scale of the potential art projects we could detect might make life easier. A superintelligence might push stars around, for example. One theoretical way of doing this is via a Shkadov thruster, which is essentially a giant concave mirror facing towards a star at a distance, where the gravitational attraction that mirror feels from the star is balanced by the stellar wind trying to push the mirror outward. The mirror would reflect the stellar wind and the star's own light back towards the star, and because photons and particles can carry momentum, the reflected radiation would push the star in the opposite direction. Wow. Over millions of years, it could, in theory, move the star many light years. If an alien superintelligence has an artistic leaning, it may wish to assemble geometric shapes out of stars, such as Klemperer rosette. This is a gravitationally stable system of 6 objects, in this case stars, perhaps alternating in mass between large and small, all moving around a common point on the same orbit. Such a star system could not form naturally, and if we found one, it would be evidence for a powerful extraterrestrial intelligence. An alternative concept would be to place all of the planets in a system on the same orbit around their star. A recent study showed how it might be possible to fit 24 planets on the same orbit without them colliding. However, all of these are brute force projects. Superintelligence may be more focused on the loftier goals of just thinking or running virtual reality programs because, it's got its biological life plugged into the hashtag matrix. Processing information requires a lot of energy. And the more a superintelligence thinks, the more energy it will require. And the less ambient heat there is, the more efficient the computations run. The interior of the Milky Way galaxy is a warm place, so superintelligences might relocate to the outskirts of the galaxy where the ambient temperature drops, thus allowing more efficient information processing. Some researchers have even proposed that superintelligences might go into hibernation for tens of billions of years while the universe around them cools to just a fraction of a degree above absolute zero, which would permit more efficient computations. Currently, the universe, or more specifically the cosmic microwave background, the leftover radiation from the Big Bang, is 2.73 kelvins above absolute zero. And what would they be thinking or calculating? That's not a question we can answer, but we don't need to. All we have to do is find evidence for their presence, whether it's a Dyson swarm, a Shkadov thruster, a Klemperer rosette, or activity on the edge of the galaxy. And perhaps if our own AIs arrive at the singularity too, that could give us some insight into the greater intelligences of the universe and what they're spending their time doing. So, fascinating article, Keith. I really appreciate that. Go check out Keith Cooper's work on space.com. I'm gonna end with this, because this is a whole other topic that I want to bring an expert on, but I haven't found like the right expert because this is super specific. You talk about, like Michio Kaku, and you have guys like that are super into like string theory and how we're all on this string that operates at like 11 dimensions above where we are right now in the third dimension. Or I guess we're 4-dimensional beings because we experience time, but we haven't controlled time.
Right.
We can move through space, but we can only move one direction in time. So I guess we're 3rd-dimensional beings that dabble in the fourth. But we can't control the 4th dimension. When you think about quantum computers, I think the key to creating an intelligence, like an actual artificial general intelligence, the guys on ChatGPT are trying to do this. I think the only way that they're able to do that is when the quantum computer is created and can be used. When the first quantum computer is able to function, then we're going to be able to see an artificial general intelligence of a significant magnitude come out of that, because the quantum computer makes our computers, our most powerful supercomputers of today, look stupid. I mean, they're just like toys. It's like
what do you mean by
Legos.
function, though? When you said, when it because there's quantum computers that function right now, and they're currently in the process. Like Google has a quantum computer that they currently have.
But it only operates very specific things, like a computer that's fully operational. It's a fully operational battle station. I want a fully operational quantum computer that can do everything. That's what I want it to be able to do. We don't have that yet. We would know if we had that. We don't have that.
Right. I know that the capabilities. So I just looked it up.
We're getting
real quick.
there. That's
storing and processing.
That's
is
something
really
we will
what,
see in our lifetime, I think.
Right.
Is a quantum computer, which is perhaps why at the very beginning of the article that Keith Cooper suggests that scientists are like, maybe by 2030, 2045, we could have this artificial general intelligence. And we're over here like, nah. But maybe we could, because I think that potentially in that time range, and it's projected. I don't have any articles about this. I just remember hearing it in an interview with Michio Kaku that he did on a YouTube channel that I watched, where he said, like, in the near future, we will have a fully functional, like, supercomputer that's a quantum computer. And that's going to break everything that we know, because it can do the computations that we can't do. Like, all of the equations on how to, like, unlock time travel are so intense and so mind-numbing that we can't do them. It would just be able to compute it. Like that.
And Google has a quantum computer that can execute calculations in mere moments that would take the world's most advanced computer, like you're talking about, centuries to be able to complete. So like in 2019, a Google quantum computer achieved quantum advantage by performing a calculation that would have taken thousands of years on an ordinary computer. That was some scientific American.com. And that was, February 2020? Yeah, February 22nd. Was when they were able to achieve quantum advantage. But I think that's just showing the demonstration of the computations, and it's not like, like the internet where you're pulling information and data and like being able to process it. They're just trying to run these simulations to see how fast they can get these qubits, which is what they base the quantum computer, like instead of just bits, ones and zeros, the qubits allow and for the computation to be unimaginable. That's what, like, we can't even fathom how fast it goes. And so having the amount of qubits is what we're trying to build out right now. And it looks like Google's quantum computers have about 70 operational qubits so far. And they're currently trying to build on those. And so when
imagine if you had a million of them.
Right.
That's what I'm saying.
Yeah, like how many bits is a regular computer run on?
Right. And then you get into the whole discussion of, you could theoretically then send somebody to the edge of the galaxy and, using a quantum computer, break the laws of physics and be able to communicate with them in real time thanks to quantum entanglement.
Yeah.
Using quantum computers, because of how that works. I'm not even going to try to explain it.
We're really,
I'm not even trying to explain it.
We are trying to tow around with things that we have not researched. We are just trying to like put into words just how complicated like quantum computers are.
Yeah.
But it maybe will allow us to do the things that we want with artificial intelligence that we have no clue how to do right now, such as figure out what dark matter and dark energy is.
Well, and my points of all of this, to kind of ring it back home, my point of all of this is that we have these AI algorithms and tools and programs that are running on our computers today, imagine what it would do if you plugged it into a quantum computer. Like if you have a computer that runs on 1,000 qubits, I don't even know what the heck that means, but let's just say it runs on 1,000 qubits. And then you say, okay, now do your computations. What would it be able to do? And that's what I'm getting at. I think when by 2030, 2045, perhaps, which is where they're getting those numbers from, if we're starting to see mass production of quantum computers, not like, I'm going to take my quantum laptop with me, it's not like that, but like maybe the capital of every state in the United States has a high-powered quantum computer. There's 50 quantum computers in the US, bam. And it helps control the government. Control is a terrible word. It helps operate the government. It goes through and works out some of the kinks that the government is able to do using artificial intelligence. Crazy. That's one step in a direction that sounds positive to me at face value.
Right.
So that's all I'm saying.
No, I get it.
And then that's where you might start to see some of these super intelligences. But on our computers of today, we just can't do it. The technology isn't there. So that's why I'm saying quantum computers are the future in terms of artificial intelligence, and then by proxy, space exploration. What if you could put a quantum computer on, the International Space Station? Then what? What could you do with the International Space Station?
Well, this was something that I was thinking about when they talked about the states that these quantum computers have to be in.
It's
they
like
have to be
super
so cold. And
Yeah.
I was like, what's really, really cold?
Space.
Space. And I was like, oh, maybe
you go.
gets the wheels spinning a little bit, and then I'm like, okay, then what are the qubits? Like, who has the most qubits? Well, Google has a lot of 50 to 60 qubits in their computers. IBM though, apparently they have a super quantum computer like 433 qubits. So
Bruh.
maybe we'll just have to have an update on the occasion of the podcast of like, okay, now we're at this many qubits, now we're at this many qubits, and then we'll just keep tabs, because I think the more qubits maybe that we have in these quantum computers, the closer we're going to be to maybe expanding our consciousness.
Yeah, I think so too. And I will close the show by saying that it is in our work that we're doing to acquire guests to find somebody that is an expert on quantum mechanics that could talk about using a quantum computer in space exploration, in artificial intelligence, and how that would work. This necessarily wasn't a space-ish podcast. We talked a lot of things about space. This is also an artificial intelligence podcast, which I thought was interesting. It's the space between. We're talking about astronomy, but how our tools on Earth are able to help that. So I thought that would be pretty relevant for today, all things considering. So Dawson, any parting words on how we're doing artificial intelligence and what we should be hoping to see in the future?
Just the wonders of it all is really what I come back to, and why I'm so thankful to be able to understand and discuss the things that we've had access to through the use of the internet, and knowing that this is a tool that allows us to continue to grow our knowledge and communicate about that is what really inspires me to further the technological advancement of AI and not put a hold on it like some people say, but instead figure out how to build the security and the measures into it to protect our data, and to be able to understand how quantum computers are going to one day maybe break those cybersecurity things, and how then we're going to have to rebuild cybersecurity through the quantum computers that will help us, and having the AI assist in that, and creating a space where we can understand what's between.
Or help us understand the space between. I'm totally here for that. All I heard from that little epic monologue that you gave
Rant in a way.
was Anakin Skywalker saying, I have created peace, justice, and security for my new empire. That's all I heard out of that. So Dawson, the evil space lord, and his quantum computer. Yeah, it's all good.
It's
all good. It's all good, as we say here in Kansas. All right. Appreciate you guys tuning into The Space Between, our episode with Dr. John Mather, the Nobel laureate in physics and current chief astrophysicist for the James Webb Space Telescope. Will be going live next week in video and podcast podcast format. So we're excited to be sharing that with you. If you want to engage with us, go check out our website, www.spacebetweenpodcast.com. Join our Patreon, $2 US dollars a month. Allows you to join our own quantum computer. It's not an actual quantum computer, but that's what we're calling it. That's what we're calling it. Our own Discord server, known affectionately as the quantum computer. And you can engage with us in that way. And then also, if you want, you can do $5 a month and get exclusive content that you won't get in just the podcast. So that's exciting. Maybe some exclusive interviews, Q&As, that kind of stuff. You want to pick our brains, you can do that through our Patreon. If you want to be a guest on the show, reach out to us at Space Between Pod on Instagram, or you can send us a message on Facebook. Just look up the Space Between Astronomy podcast on Facebook. It'll pop up. And be sure to be looking for our AI-generated art that we dropped today on Instagram. Believe it or not, it's pretty cool. It was pretty cool. So appreciate you tuning in. As always, my name's Kolby Van Camp here with Dawson Wagner, and you've been listening to The Space Between.